All right, friends. So like I told you, we will be moving on to scientific notation, and that is what we're discussing now. That's why you had to learn how to put large exponents into your calculators. So today we will discuss if you're given a number in standard notation, how do you convert that number into scientific notation? So um, standard notation and scientific notation. The big thing you have to understand is there's rules for scientific notation. Converting a number, a big number. So standard notation is how you normally see numbers. So you write a number as 1,000. You might write a number as 221. Okay, they're normally how we write our numbers. But what scientists have discovered and mathematicians have discovered is once numbers get really large, it's a lot easier to write numbers in scientific notation. So they developed a shorthand form of writing really large numbers. So in order to write these really large numbers, though, you have to understand the rules that apply to scientific notation. So as you can see, I wrote 93 million as down here as 9.3 times 10 to the seventh power. How did I figure that out? When you write scientific notation, you have to, first rule is you have to have a number that's greater than 1 but less than 10. So when I'm looking at this, okay, I have to pull the number that's greater than 1 but less than 10, okay? So what I'm doing is that's why I put the decimal point between 9.3, okay? I couldn't choose, so you first look at 9. Is 9 greater than 1 and less than 10? Yeah. So I take it out to the next. So I put a point, well, before I put the point. So I take it out to the next. So 3. Is 93 greater than 1 but less than 10? No. So now I know I need to put my decimal point there. Okay. So now I say, is 9.3 greater than 1 but less than 10? And the answer is yes. Okay. All right. So that's where I got my 9.3. All right. Um, Another key rule factor you have to understand. I think the PowerPoint has all the rules, but it has to be uh, 2-digit numbers. It can't be a 0. So obviously, if I did 0.1, so this is a second rule. If I did 0.1, is that a number greater than 1 but less than 10? No, this is not greater than 1, so it doesn't work. Okay, so it has to be 2-digit numbers. Okay, it can't be a 0. Okay, it has to be a number greater than 1 and less than 10. Okay, so that's how I chose the 9.3 from this number. So now I have 9.3. How did I know 10 to the 7th? Okay, I want to get back to this number. This is the number that this is supposed to represent. So this represents this number. So how, if there's a decimal point right here, how do I get back to this number? So I would have to move 1, 2, 3, 4, 5, 6, 7 units. Okay, so that's where I got the 7. And I'm moving to my right. Okay, think of a number line. So if I have a number line, okay, and this is my 0, if you're right, you're positive. If you're to the left, you're negative. So I know that's a positive 7, okay? So if you're moving to the right, it's a positive 7. Another also really easy trick is if it's a big number, you know it's positive. If it's a small number, you know it's negative. So what I mean by that is We're going to have to erase this to make room. Say I didn't have a huge number like this. So we all can recognize this is a really, really big number, okay? That's a big number, but pretend that was not the number. Say the number was instead okay. So say the number looked like that. Okay, so it's not a big number, it's a really tiny number. So if it's a really tiny number, I know my exponent, instead of it being positive, it's going to be negative. Okay, so let's try to go back through these rules to figure out how I would figure out the scientific notation of a tiny number. So again, it has to be greater than 1, but less than 10. So I can't use any of these zeros. Okay, I have to have the 9 and the 3 in there. So I'm going to put 9.3. Okay, now again, remember, this number, my scientific notation number, is supposed to equal, it's equivalent to this number, because this number is representing this number. The only reason I'm using this number, it's a shorthand form, okay? So I'm just trying to write something quickly, okay? This is what scientists, they like to be able to just jot things down real quick, okay? So this number is supposed to be the same exact thing as this number. So I'm thinking, how can I convert this number back to its original form? Well, if I put the decimal point here, how am I going to get back to where it belongs? There. I got to move 1, 2, 3, 4, 5, 6, 7 spots. So I'm moving 7 spots. Okay. But I'm moving 7 spots to the left. So if I'm moving to the left, it's now negative. Okay. And that's why that one's negative. Whenever you're doing scientific notation, the other rule that I should have mentioned is it's always a number multiplied by 10 to some power. So it's always multiplied by 10 to some power. So you're always going to have the base unit. This is called a base unit of 10 to some power. And you have to figure out what the power is. Okay. So let's try a couple and see if we got this down. Okay. So the first one I did for you, but let's work through it together. So we have, so first thing, let's try to identify if it's going to have a positive or a negative exponent. Let's just go over here. So this is a huge number, big number. So would you think positive or negative? So remember, big number, I said positive. So this one would have a positive exponent. This one is a really tiny number. So if it's a tiny number, it's going to have a negative exponent, okay? This one is a big number again, okay? So if it's a big number, it's going to have a positive exponent. This one is a really tiny number. So again, this one's going to have that negative exponent, okay? So now let's see how did I figure this one out? It can't be a 0. Remember, it has to be a non-zero. It has to be a number greater than 1, but less than 10. So I have my 2.4. The base unit is always 10, so you're always going to take your number and you're going to multiply it by 10. How did I get to the 5? So if I put a decimal point here, okay, I want to get back to the original number, which means the decimal point originally is here. It's all the way in the back. Okay, so I'm going to go 1, 2, 3, 4, 5. Okay, and that's how I got 10 to the 5th. All right. Let's do this one together. So it has to be a number greater than 1 but less than 10. It can't be a 0. So, and you have to include both of the digits, okay? All digits must be included, okay? So we have 7.3. You always have your base unit of 10. I'm just going to erase that for you. Okay, so remember, if I put a decimal here, I need to get back to my original. So I'm going to move 1, 2, 3. So I'm moving 3. Okay, we already decided it was negative. So it's negative. Okay, again, it's a small number. So it's negative, and you move to the left. So it's negative. Okay. This number. So you have a 3. So it would be, you could either write it as a 3 or a 3.0. It's up to you. I always do it that way, just so you know. Times, okay, you always have your base unit of 10. All right, so if I put it right here, it's a 3. Technically, the decimal was back there. Okay, I want to move it back there again. So I moved it 1, 2, 3, 4. Okay, so it's going to be 4. We know it's positive because it's a big number, and we know it's positive because I moved it to the right. Okay, this one. So again, you have to include all of the non-zero digits. That's really important. You have to include all of the non-zero digits in your first number. So I have, my first number is going to have to be 9.687. And that is correct because it's a number greater than 1 and it's still less than 10. Okay, you can't drop off any of these digits or it's not. Remember, this number is supposed to be representative of this number. It's supposed to be the same exact number. It's just in a different form. So if I drop off any of these numbers, it wouldn't be the same exact number. Okay. Remember, you're always multiplying by the base unit of 10. So you're always going to multiply by 10. So now if I put the decimal right here, okay, how do I get it back to there where it's really at? I'm going to move 1, 2, 3, 4. So I'm moving 4 units. Okay, I move 4 units to my left. Okay, so if I'm moving 4 units to my left, I know it's negative, so that's going to be negative. Or you can also remember it's a really tiny number, so tiny numbers are negative. Okay. So scientific notation, converting standard to scientific is confusing for some people. So please feel free to reach out if this wasn't clear. Another big thing, if you look in my lesson plans for this lesson online, I also give you the links to Khan Academy. There's multiple videos explaining scientific and standard notation. I highly advise you also look at those video tutorials. Uh, Again, practice, practice, practice. To learn anything in math, especially harder things, you have to keep practicing. Do multiple examples, a lot of problems. The more problems you do, the quicker and easier it will come to you. Okay, I hope you have a wonderful day and I'll see you again tomorrow. Bye now.